testing business logic using DSL. And the speaker is going to be Mayank Jain. Before we start off, there's a sheet out there. You need to register, put your signatures out there. What we're going to do is we're going to have some lucky draw. There's some goodies being distributed. So make sure that you put your signature there. Okay. Brief on Mayank. He's a test engineer at Helpshift, and he enjoys controlling difficult testing problems with power of Clojure. So I'll ask him to give more introduction about himself, and then probably we can start off with this session. Yeah, thank you.
So, hi. Hi. So I'm Mayank, and I work at Helpshift as a software team test. And so before we begin, I would like to know how many of you know Clojure or have heard of it. How many of you do testing? And how many of you didn't DSLs or know what a DSL is? So, okay, so before let's just begin. So this is going to be a talk in 6 parts, right? And so first I'll talk about what is the problem, and we'll take a real world example of how we load a DSL for a given feature in a FAQS, and then a demo of the actual code. Then other features that we tested using the same ideas and same principles. And then finally, what are the advantages, disadvantages, and then we take a question answer. So, what is the problem, right? What is the problem, main problem in testing? Can anyone answer that? What are the problems that you face in terms of testing? Anyone? Sorry? What to test? Okay. Scope of testing, right? Anything? Sorry? Okay. So the main problem that I feel in testing business logic is that testing real world stateful business logic is hard. Right? And why is that? So let's just take an example. This is a state machine for a microwave oven, right? So it can go from being an idle to full power on. Then you have to set the timer, but if the timer is on and the door is open, then it does not work. You need to close the door. So on and so forth, right? So there are a large number of transition states that you can see here. And it becomes very difficult to enumerate all possible cases. Like for example, there might be about, if I cycle through this running, set timer, door open, door close, set timer, door open, door close, and then finally maybe there's a problem. Who knows, right? You need to worry about all those possibilities. So the only way is either you try to write all possible tests, which becomes really unreadable or very hard to maintain, or you skip some of them and just hope for it that there are no problems, right? So okay, let's start with Helpshift. So what do we do at Helpshift? So we are an amenable support desk for native apps. So we provide an in-app SDK to be used by our customers, which we can include in their app, and they will have two main features. So one is frequently asked questions, which customers can use to search inside the app, their app, and other is they will be able to find issues and tickets from within the app and talk to the developer. Right. So let's take a top-down view of how FAQs work at Helpshift. So at Helpshift, every customer has one domain. So for example, Supercell is there. Ghana. Anyone heard of Ghana.com? Yeah. So Ghana is one of our customers at Helpshift. So every domain has several apps. So yeah, Supercell has Clash of Clans, Boom Beach, Ghana has their own Ghana app. Then every app has several sections. So by default, we have general and general section. Then every section has frequently asked questions, like 1, 2, 3, 4, so on. And every FAQ can have several translations for different languages, right? So this is a FAQ page, support page for Ghana. So that's the domain. This is the app. These are the sections. These are the available FAQs in how to use Ghana section. And customers can search for FAQs. So by the way, if you have any question, you can just feel free to stop. So this is how you can create a new FAQ inside our dashboard, Helpshift dashboard. So you enter the FAQ title, you get the FAQ body, and you can turn off one particular translation. And you can also publish on off the whole FAQ. But what is the problem with this? Right? So the problem was that you could not share FAQs across apps. So I cannot have Supercell's Clash of Clans FAQ to be shared with any app, right? And why is that an important requirement? Because companies have privacy policy, for example, which is common across apps. There are a lot of FAQs which needs to be the same, linked together. Right now, a few weeks back, we did not support that. So we introduced a feature called linked FAQs. So what it does is, say, given there is one app which has a section general, under that there is an FAQ, right? Then you have another app, and you would like it to link it to the general section of that app. So you can sync FAQ1 to app 2, and then what happens is the translations part of both the FAQs are linked. When I say link, if you update FAQ1's body, FAQ2's body should also be updated. If you look at notice body, update body, and this has changed, and vice versa. So the main problem is that there is no master slave idea. It's more like peer-to-peer, right? Everything should be synced across each other. But rest of the data should not get synced. Everything else remains the same. Only the translations, the content of the FAQ should be synced. Everything else is isolated, right? So there are a lot of combinations to worry about. You can add an FAQ, you can edit, you can delete an FAQ. What happens if you add several FAQs and one of the apps is deleted? What happens if there are multiple translations in one app, and then there's some app that does not have that language, so on and so forth, right? So let's take an example test case for this feature, link feature. So first we'll try to add an app with only English language, then a second app with another English language, then you add first FAQ under first app. Then you link first FAQ to second app to create second FAQ, similar to what we just saw. But then you have to verify that both the FAQs translations are the same. And then you update the first FAQ, then you need to again check both of them are same. Then you have delete one FAQ. Then you need to check whether first FAQ is deleted, but second should not be deleted. Right? But can you see a pattern there? What is the pattern? There is a partition here. What's the partition? Any idea? No? So there is a simulation of what needs to be done, and there is a verification of what happened. They are two different things, but right now they are interlinked, right? And that makes it hard for me to understand, okay, am I testing, am I simulating, what am I doing in my test? And generally that's what we do. We state things, do this, check this, do this, check this, right? But they can be separate. So what are the parts of each action that we are taking? So let's take an example of this action, add app 1 with only English language. So there is a type of action that I'm doing, which is adding an app. There is a name which I'm referring to, app 1. There is an argument to this action, English language, right? And then there is expected result as per whatever is specified by the product manager, model of the system, or even my own understanding, right? And then there is what is actually there in the database. There are 5 parts to that one action, right? What if we could express this action in terms of Clojure data structure? So here, add app is being represented by this keyword called add-app. That you think of that keyword is like more like a string, right? And then app 1 is represented by that. And this with English language, this is a map, the curly braces. This is a keyword, this is the value. So I'm saying add a language configuration is in EN is stand for English. So this whole thing is one unit of action. Add app, and with this parameter, and when you get the result back, call it app 1 to refer to it later. Right? So these are the series of actions that are there, right? Same thing. Now it's a vector or an array of array. So it's an array of 3 items. First is the type of action. Second is the variable that I'm binding to, if I need to. And third is the argument. So sometimes I may not have a binding in this case. Because I'm only updating something, I don't need the result to be binding to something. Right? Am I making sense? And here I'm referring that app1 later to add an FAQ to that app. Right? So that whole English language that we were trying to describe the test is now a part of Clojure data structure. This is a DSL. So what is a DSL? DSL is just a domain specific language. Right? This is a language to describe my Helpshift system or my feature. Right? That is what a domain is specific. It's very specific to what that feature is or what your problem is. Right? So you take these series of actions and you pass it to a function called reduce. How many of you know reduce in functional programming? Right. So you pass it to reduce. So let's see what a reduce is. So reduce starts with an empty result. So this curly braces is a hash map, right? And then you take the first action, which is adding an app and calling it app. You give it a reduce and you get a result back. So this has been updated with the result. When you take this result, take the second action, pass it to reduce, get an updated result. And so on. That's it. That's the main idea. You reduce over all the list of actions, start with the whatever empty environment that you need, and then you keep updating, right? But what is the this in this? What is this? What all does it need to have? So it needs to have 3 things. One is the environment, which contains binding of all the variables that I'm referring to. So if app1 is an app ID of something, app2 is an app ID of something, which I need at runtime, right? Because this ID I cannot know before I run the test. It's something that is available only when I do an action, right? Second is the result of each step. So here I'm storing what is the action type that I took, what is the expected result which I generate, and what is the actual result which I got from the database, right? And third is the current generated expected state, right? So what happens inside the reducer? You dispatch on the action type, which is say add app, delete app, or whatever it is. Then you update the variables and arguments to its bindings, right? You call the arguments with relevant functions. You bind the result to the given variable in global data, which is that map that we were looking at. You store expected current state, store actual current state, actual current database state, and then look at it. Keep continuing. Doing that till you end of list of actions. Let's take an example. So the same example, now we'll look at it in more detail. So you start with add app1, a language configuration is nothing, this is default by default English. You pass it to, so it checks what is the action type. So the action type is add app. Okay, call the relevant multi-method. So in Clojure, there is something known as multi-methods, where you can dispatch on whatever data you want. In this case, we are dispatching on the action type. This is the first thing of the list. Then you check update. You update the variables and arguments to its bindings. In this case, there is no bindings in this argument. So we just skip it. We take the same thing. Then you call arguments with relevant functions. So this data is converted into this, right? And then this, so in Clojure, or in list, first thing of this open parenthesis and close parenthesis is a function call, and everything else is an argument to this function. So here I'm calling add app function, and I'm passing this argument to this, which will return an app ID of the app that was generated. So now I need to bind the result to the given var and global data. So what is the var? Var is app1, and what is the data? Which is whatever is ID that was returned by add app. So this is the update that result that we are passing around, right? Inside the environment, I have apps namespace, Inside apps, there is app 1, which has this app ID. Why do we need this? We'll see later. Then you store expected current state. Since I am only looking at FAQ data, I do not store anything. Skip. I don't store the actual current database as well. Next. Again, go to the second action, which is adding another app. Second app. Same thing. Dispatch of the action type, add app. Update the variables, arguments to its binding. There is no variable binding. Call arguments with relevant function. We call it the same thing. But this time, the result that you get, you bind app2 to the app ID that you get. Right? And then you store expected current state and store actual current state. This is not there. But now this time we'll try to add an FAQ and dispatch on that. So what is this action type? Add FAQ. Sorry. And then this time we are trying to update the variables in arguments to its bindings. So here there is a variable which is app1. So we look up. So we look up in the environment, see what app1 is referring to. We get app ID 970. We replace this whole argument, update it, not replace, update it to the app ID that we are referring to at runtime. Then you call args with relevant function, which is this. But this time instead of we don't pass this, we pass the updated arguments, right? Because this is the runtime information that we can have only when while you run the test, not before that. Then you bind the result to the given bar, which is FAQ1 ID is being stored here, right? And then store the expected current state of FAQ. So you get some result, but you generate some result of what you expect current FAQ1 to be in this, and then you store the actual what you get from the database. That's the key idea. But what happens once you're done with that? At the end, what do? You compare expected versus actual for each step. So let's see an example. So you compare result for first action. You take expected data from my generated result. The result that you are generating after each step, according to your own model or whatever the specification is. You get this back. Then you get data from actually what is there in the database. You get this back. And then you compare if they are the same. If they are, it passes. So that step is passed. And you move on to the next action. You get another generated result. In this case, the title 2 you're looking at. And what is there in actual data in DB is title 1. So somehow it did not match. There is a mistake. Either in your test or in the backend code. Right? So this is. So let's look at demo. Anyone has any kind of question? Yeah.
In general, when you are saying it is a DSL created, and the production code uses same DSL?
No. I'll show you the production. It's different from the production.
Ideally, you can use DSL as a normal regular production code, right?
As a
code. Like when you add actual act, or you add any effect, you can call this code.
We could do that. I have focused more on testing. We can have a very generic to even write the code. Possible. The DSL is a very generic thing. What you do with the DSL is up to you. Right now I'm using DSLs to test. You can use it, and in fact there are people who have done that. Have written DSLs very specific to their domain. Maybe banking apps and others. They have. It's possible. So here is a test, the same test that we were looking at. So here I'm saying add an app, call it app1, right? Then take out the ID, take out the section ID, then again bind it. So this leg allows me to give a name to whatever the result is, right? Then you create another app called app2. Take out the section, then you create an FAQ, call it FAQ1, and so on. And then in between, I need to fetch. So Mongo is one of our database source of truth. So I'm fetching Mongo. I'm fetching for Mongo for second FAQ. Again update. Again Mongo. Fetch from Mongo. Again update. Then finally a delete FAQ. Then fetch from Mongo. Then finally I'm comparing all the results, whether they are matching or not. And FAQ, this FAQ was deleted. So this result I want to check that it's nil, right? So this is not very easy. Even if you know Clojure, it takes a while to understand. Okay, at what step am I doing what? Right? So I'll just take this. Run the test. I get a true bar, right? But this was not very helpful. So let's look at the example that we were looking at. So here is the same test, but in terms of the Clojure data structure. So this is a difference. That was an actual Clojure data. This is a simple Clojure data structure, which I will evaluate into an actual Clojure data later. So here I'm adding one app, then I'm adding second app, I'm adding one FAQ to app 1 here. Here I'm adding the FAQ 1 to app 1. Then I'm linking FAQ 1 to app 2 and calling that result as FAQ 2. Then I'm updating FAQ 1 in app 1 with this new translations. Similarly, update again for FAQ 2. Then finally delete FAQ 1. And then there is a function which says run FAQ actions. You'll see what it is. And then finally check whether in Mongo everything matches or not. It should finally return true. If it does not, there is a bug somewhere, right? Let's just look at that. So one thing in this also you need to do in generator testing or this kind of DSL testing is that not only you just return true or false, you should always have a debugger. What is happening? I'll talk about the debugger. This will actually print what all is matching and what all is not matching for each step. So it finally returns a true bar. But let's see what it returns. So for the first action type, add FAQ, I am ignoring adding an app because that is not required in my testing, right? So what is the diff that was only in database? That is not in expected state, but is there in Mongo state? Nothing. What is there only in expected Mongo state? Nothing. What is common to both actual and expected? Everything. That step passed. Right? So it has a FAQ ID, linked FAQ IDs and translation. Second, we move on to link FAQ. Same thing. Update FAQ, same thing. Right? So you can see it's trying to see whether both of them are same. If they are, then everything falls under the common part of both actual and expected. So let's jump into what. Yeah.
When you are saying add FAQ, and internally you are actually verifying, like nil is your expected and actual, right? Or that's it.
No, so this.
So not for add FAQ, but for add initial what you
Add app, yeah.
right? It means when I call add app, your DSL actually is doing two things. It is also calling verification.
It is also calling verification. Yes. So I'll talk about this. So the idea is your test should only tell you what needs to be done, and there is a model which behind the scenes also generate what it's supposed to happen, and then what is actually there, and then you compare both. Right now in this earlier test, it mixes what I need to do and what needs to be there, and where I need to get from. There are three different things, right? But the test should not need not do that. There is some other function that can do that. Right? My test should only represent test. And we'll see why later we are done. Does that answer your question?
Yeah, it answers. At the same time, what you are saying is it is strictly tied up with the required requirement of the test.
That is why it's a DSL, right? It needs to be specific, domain specific language.
As a domain specific, I cannot use add, but by another thing where I don't want to use verification or something.
You can just throw it as then don't look at it. So that is up to the function that is going to do verification. Your function will say, oh, okay, I'm adding an app, don't look at it. I'll just throw it. Right. So you decide that. So this is not generic enough to do it right now, but the point is that you can go in the direction. It's up to how much time you have, right? You do also have deadlines to ship. But again, so here is the run FAQ action, which is the reduce, which I was talking about. So reduce takes an action, right? List of actions, and if you don't pass an environment to start with, it will start with an empty environment, which is what I was talking about. But if you pass something, it will start from there, continue from there. So let's take a simple example to see what's happening. So here I'm only adding one app, passing it to run FAQ actions, and see what happens. So, and I'm binding it. And I'm binding that result, final result to actions 1. So let's see what is the environment. So this, what it does is, inside actions 1, it will fetch the environment key, what is the value of that, and just predict it back for easy reading. So here it says there is an app called app1 where I also have data for section ID and the app ID, which I will use at random. Let's take a bigger example then. So here I'm saying run FAQ actions, add one app, add second app, and bind app 1 to FAQ 1. Let's see the environment for this one. So here you can see for that app 1 and app 2, we have FAQ IDs. We have what FAQ ID it has, what app ID it has, and what section ID it has. And also for FAQ 1, I know what FAQ ID it has. This information this is how I say, okay, when you're calling FAQ 1, this is what I need to actually say. And this allows me to not mention what runtime information I need. And no need of binding or anything of that sort, which I was doing in my older test. Right? Let's look at the result of this. I get this huge data. Basically, this has 3 things. It's a list of results. So let's look at only the keys. There is an action type. There is an actual Mongo data that is stored. There is an actual Elasticsearch data which I get. And there is finally what is the expected state of my system. What I expect it to be, which is generated by me. Right? So let's look at that. We have the 4 things. Action type. So this is useful in debugging. If it says, I know what I was trying to do. Right? This is what I get from the database. This what I get from Elasticsearch. And this is what is generated by me at runtime. There is a function written by me. It's saying if I add an app, if I delete an FAQ, what is supposed to happen with the given content. Right? But if you look at it, this does not really match with this. So you need to take this state for each result pass it to a function which will generate the expected actual Elasticsearch and expected normal result and actually Elasticsearch. Right? That's it. That's all you have to do. So how does it do it? So this reduce passes the data to this something called as multi-methods. Okay. So what multi-method does is you define how do you want. So think of it like elegant cond or a if-else condition, right? So what is an if-else condition? You have some predicates when you are trying to say if this is the data, do this. If this is the data, do this, right? So think of multi-methods where I'm saying given whatever data, dispatch on the action type and call the relevant test method. Right? So this allows me to separate concerns of what for each action type. So here if I pass add app, this def method gets called, which does the whole computation. If I call add FAQ, this gets called and so on and so forth. Right? Is that clear? So what are the several things that inside this def method happen? I'll take a different example. Let's take link FAQ. So what is the kind of data that can be passed to link FAQ? The action type, this is link FAQ here. This is how you dispatch to this call. Then there is a variable which you need to bind the final result to. Then there is an argument which can have some bindings which you need to look up at random. Right? So you resolve first, you take out the bar and you resolve it inside the environment. You get the data and you pass it to the actual call that you need to make, which is the code which actually does the side effect. This link FAQ is what you really needed to call the test, right? But this has been hidden from you through the DSL. You get the ID back of the new link FAQ, and then you add that FAQ ID to the given variable link, which is FAQ1 in the example. Then you update whatever apps you have, and then finally add the result. So here I'm saying get fetch the longer results, fetch elastic data, and add it to the result command. And then continue with that. That's it. Does that make any sense? Anyone have any questions on that? Or you want me to take another example? So let's take an example. Let's take the bigger example. So here is all of the whole example that we were taking. Add app. Add app 1, and add another app, then add an FAQ. Then add an FAQ, link FAQ, update the FAQ, then finally take the result. Notice in the action, there is a delete FAQ as well. How does it affect the result that is stored? Let's look at it. First, let's look at the environment. So here you can see both the FAQs. Even though I deleted FAQ1, I did not delete it from the environment. Why? Because I need to know later if there is a reference to FAQ1, I need to know that this was an ID, but in database is not. Otherwise, I will not be able to check on deleted stuff. Right? This was a mistake. Initially, I deleted it. Then I realized, but how will I know what if that ID is not there? Then I stored it. right? So these are the like ideas you need to understand according to your DSL, like how much data to keep, how much data to throw away, right? And then you can move on to make it more generic and more general. Let's look at the result of this. It's it's a big. It's similar to what we looked at. You have the action type, you have the action logo, DS and state for each of them. So there is actually, let's look at the how many results we get at 5. So for each step we have result, then you have to compare each of them and then see what happens. So what are the approaches that we can use to verify? Right? What are the different combinations that we can do? So one is what we normally do. We have hard-coded actions like we saw, and then we have expected hard-coded output. After this step, this is what should happen. After this step, this is what should happen. This is the first example that we saw, right? Second approach is actions are simulated using your DSLs, but the expected output can be hard-coded. This is possible if there is no runtime information, like an ID. Let's say after doing series of actions, I know what the count of some number of FAQs that should be. That I can have as a hardware. But always this may not be possible. Right? So this is where the DSL comes in. You have simulated actions, but generated expected output. Right? And then finally the holy grail of testing. You have generated actions, generated action output, expected output. Right? So there are 4 different strategies you can do, right, depending on your use case, and each of them has their own trade-off. So what is the advantage and disadvantage of having hard-coded actions and hard-coded expected output? It requires no extra knowledge for anyone to go and fix it, right? And this is a problem that you need to worry about. If you have a very large team, it should be easy for others to look at your test because it's not going to be something that you will maintain it for your whole life, right? What is a disadvantage? It becomes difficult to enumerate all possible cases. And modification is hard. If you need to change anything, you need to read the whole test. You need to figure out where exactly to go fix something and change that. But false negatives are not possible because the output is hard coded. It knows exactly what it should come. There is no generation of that. It cannot go wrong unless the output itself is. Second approach is that simulate list of actions but hard code final expected output. This requires knowledge in the DSL. Like that, but the DSL that I was looking at, but you just can't go and edit that or write one. You need to know, okay, what are the different types of actions? What am I supposed to pass this type of action? Because it's just data, right? Even your IDA cannot tell you for this type, these are the arguments that you can pass. Right? Well, there is a maintenance overhead for maintaining that DSL over a period of time. Right? If there is a modification, you need to flow fix it. But it becomes easy to enumerate. Right? If there is a slight modification in the test, I can just modify that DSL, boom, the test is ready. I don't have to worry about, okay, what is the new output that needs to be made. Right? It becomes very readable. If you saw the first example and second example was much more readable, even to a new guy, what this test is about. Right? And one of the side effect of this is that it becomes shareable with devs to simulate bugs. So I used to, when we used to find bugs in our backend, I used to just create the data, put it in the Jira ticket, share it with the dev, used to copy it, put it in the REPL. He has a state, he can see what happened. Then he fixes it, he runs it again, he sees that it's passed, he closes it. This was a really, really nice approach that we used to have. We used to cycle using just this. Instead of me telling in the ticket in English language, hey, do this, then do this, then do this, and you have to do it every time. He needs to check whether the code is fixed. Right? And expected output may have data which is available only at runtime like FAQ IDs. Right? So this is only valid if there is runtime, there is no runtime. But then this approach that we took, simulate list of actions and generate expected output. So this allows us to have runtime data in the expected output. That is the biggest advantage of having this approach. But the problem is that there can be false negatives. Like sometimes what happens if your model is having the same bug that the dev has? What if your understanding is not correct? What if you are not looking at the right thing? Like in your generator testing? That is a problem, but that is easy to fix because we can solve it. Right? And then what is the finally only claim on us? You generate both actions and both expected outcome. You just say go, try 100 combinations. Tell me if it's possible. Imagine if you could do that with your domain. Right? If I tell you you need to test this, do you have enough confidence? I don't know. I've run 1,000 tests. I can't possibly write 1,000 tests on my own. Right? And this allows you to have shrinking of failed tests. So anyone heard of test.check? No. So okay. So test.check is a library that is available in a lot of languages, Erlang, Scala, Clojure, Haskell. I think it was originally written in Haskell, but Erlang. It was originally written in Erlang by this guy called John Hughes and others. So it allows you to state what is the property that your test should hold, and what is the input domain for your test. So for example, if I'm trying to write a test for reversing a list, what is the property of reversing a list? And if I reverse it twice, I should get the same list back. So given whatever input list, this property should always go. So what it used to do is, what does is, if it finds a failing test, it will try to remove elements and see if there is a smaller test case which still fails. So what it allows you to look at exactly what you need to do, because that's what you do even when you find a bug. Can I reduce this input size and see what is the minimum failure? This library does that for you. Right? So this DSL is a step towards going towards that. Right? But there is a lot of maintenance of it. You need to worry about how you will do for both the model and the generation of it. Right? So we look at the same thing, the thing that I talked about, generation of both actions and the expected output with the feature which we had called issue audit trails. Right? So what is an issue audit trail? It's simple. You maintain a logs of who took an action on the issues and what action you took. So this was useful for our customers and even for us, like what happened behind the scenes. Right? So who are the types of users at Helpshift? We have app users who are our customers, right? And we have support user, which can be of two types, agents and admins. Right? Then what are the types of action that these users can take? App users can create an issue, reply to an issue, etc. Admins can also create an issue, reply, but they can also resolve the issue. They can add tags to them, and so on. Similarly, agents can also do similar things. Right? So this is an example of an issue which was filed by some customer. This is the text that they sent from their app. Hello, I have an issue. So this is the app user. This is done by the admin container, right? And this another reply was made by the agent. So what is the issue audit log that we have? What is the issue audit log that we have for this issue? This is for the admin. This is again an issue audit log, and this is the for issue. Right. So this is what I needed to test. So you can understand how many combinations that I can worry about. What happens if user replies, then admin replies, then user replies, then admin replies, then agent replies, and admin. So many combinations of combinations that can work. So this is where generative testing comes into the picture. Let's look at that. So here is the finite state machine I have written to represent the possible set of actions. So what is the structure? You have a from transition where I'm trying to go from state. Then you have a key map which contains keys of what are possible transitions that can happen. But to go to that transition, what is the list of actions that I can do? Let's look at the actual code. So here it says when you start, you can only create a new issue. You can only do a new issue. And there is only one possible action, which is the user creating the action. So this DSL is slightly different, as you can see. right? So there are three parts, there are three things. Who is taking the action? So user, admin or agent are possibilities. What is the action type? What is the argument? Similar pattern, slightly different, but that's similar kind of use. When you create a new issue, you go to this way, right? And here I can go to new issue, I can go to in progress, or I can go to resolve. To go from same to go to in progress, either an admin can reply, agent can reply, admin can insert an FAQ, agent can insert an FAQ, and so on. So this is that similar to how that we saw that microwave oven finger shape machine. If I do this, then I can go here. From there, I can do these combinations. From here, I can do these certain combinations and cycle back. Right? So this is the model. Model of what all possibilities are. Right? And here I've written a function which takes a starting state, which is just start, and then randomizes possibilities of what all I want to do, and then sees what is the expected output matching with the actual output. So how many actions should I do? 20, 30, 50? Let's say 42. Sorry? No, you'll see. The past. So here you can see all of the different possibilities that we tried. And I've reduced the set. There is a bigger set actually, but I've tried to minimize it to make it more readable. Right? So you can see that we try to do a lot of different things. And it also returns what all I try to do. So it says what create issue, how user try to take an action, then auto assign, what apply, and so on and so forth. So many and what I got, which is matching, so there is no difference. Let's try to wrap it up.
How you adjusted that issue is closed and it is not replying to that?
Yeah. So when the issue is closed, which is resolved, only the user can reply. In that state, I'm mentioning that, right? And when there is a user reply, there needs to be user reply for admins to go back. So here, from result, I can go to in progress start, which is a special state. Then in progress start can only go to in progress, and from there admins can. So that's what I was trying to say. You need to specify that. Right? You need to maintain this. So if there is a new, say, user, you need to go update this. But that's it. You don't need to go change all 100 test cases and go update. It just generates it. So I'll try to, these are actually all possible combinations. Let's try to run this. Sorry?
Does that randomizing take care that all the paths are covered at least once?
No. You can, it's up to you. How do you want to run? You can give weights. Like you can say, after creating an issue, there is an 80% chance that the admin will reply. And 20% chance that the user will again reply. Asking, you didn't reply. What happened? It's up to you. You can decide on that. That's the beauty of having a DSL, right? And find state machine. You can say, after this, there is only 1% chance, because that's what happens in the production code of this happening. You can simulate an action production. Up to you. I haven't.
Actually, I'm his colleague from Helpshift. So one of the
problems is that whenever the business logic changes, like let's say we add another category of user, let's say there is a supervisor or something like that, my state space suddenly explodes, and the number of permutations that can generate that goes exponentially. So actually, it's really hard to enumerate every single combination as the business logic becomes more complex. But what Mayank has also found and what we have found is that this allows you to dynamically explore a lot of different options that you will never be able to do as a tester if you're not if you don't have a tool like that in your hand. Like I might be able to like these written the model that is specified is something that the business logic database should have. But what if I change the model? It does things that the business logic doesn't have. Okay, and that does my system explode. And then I just need to like the issue resolved case here saying only the end user can reply. So what if I put an option saying that an agent tries to reply? Does my application blow up? Okay, so and it may not blow up in some cases because there are boundary checks in the backend code basically drop that request if that happens. But under certain conditions, I cannot manufacture in advance. So I cannot even predict that my application might blow. So it kind of gives that flexibility to explore those kind of parts.
So I ran it again. And this time it failed. So let's see what happened. So it's saying found mismatch, expected trace. I was expecting 124 trace, but I got actually 123. This is hard to understand. I can't locate all of the data and figure out which trace was missing. So this is generated by me. Like so, there is a diff algorithm that is embedded in this, which tries to diff and see what exactly was mismatched. So I'll search for failed. Change in this code. So basically, what it will do is it will tell you exactly what is the diff, where it has failed, and then you can go and fix that. Right? So what I did was there is a bug in my test where if the data is in HTML, right, it does not modify the input expected result to have SSS checks, basically, right? So this effective has HTML data, and my expected data does not expect it. It expects it to be an actual HTML, not escape HTML. And then there is a failure. So you just need to fix that, and then you have a test. HTML. So what are the advantages of writing a DSL? You can find very hard to find bugs. Right. So one of the issues that we got in issue audit training was that if the order is just right, only then there will fail. Because two audit trails, there are two types of audit trail. One is single audit trail and one is a dependent audit trail, which needs to go together. And because there is a pagination in our issues details page, they get chopped off, and then audit trail comes in. And that audit trail has to be exactly at the bottom for that to happen. For a long time, we did not discover that bug, but when we wrote this, it started generating and then it failed, and then we just went back and discovered, and then we had to actually go back and fix a lot of code because they didn't expect, right? Because they didn't handle this. Second was timing issues. Because it was trying so fast and so many combinations, if the order is exactly right and the order mismatches. So audit log 1 and audit log 2 will start. And why was that? Because on Postgres, the key that you are sorting on is the same. It can return in any order. So they were sorting on the action taken at not when the audit log was actually created. So this is another bug that we found, right? And then increase in developer tester and productivity. As I said, like I used to share literally the exact data, give it to my dev, used to take it, pass it, and then say, okay, test passed. Right? What is the disadvantage of writing in DSL? Maintenance is high. Right now, there are very few in the team who actually know this or understand it. We haven't done this for every feature because we do have time constraints, but we are definitely trying to do this because this has a lot of value in terms of testing. And there are other problems like if your DSL is just data, and if your backend code changes, you will not get compiled and because the compiler does not know what this DSL is about, whether it is going to dispatch on what function, it does not tell you. When you actually run the test at runtime, it may throw you proper or error depending on how you do this. Or it may fail much ahead in the pipeline and then fail randomly and then you have to go and fix that and understand it. This was another problem that I found. And you have to educate your team members. If you have a large team, it is important. The conclusion is that DSLs, so think of DSLs as a way of workflow of writing tests. You know exactly where to go, you know exactly where to add or modify or update. If you go by the standard way of testing, you have to start pretty much from scratch right, to write the test. Then there is a separation of simulation and verification. Right? I can simulate but not verify. I can just have hard-coded output in expected steps, but generative or expected output, and so on. Or a combination of both, like you just saw from here. And it allows a step towards render testing, which you can use something as a test check to use string data.
So, for a given business logic step, so you run it for the 50 combinations in that, so that passes. Okay, now if you run it for multiple time, and in those 50 combinations, there is a dynamic combinations, right? So that can be possible, right? You can get a failure in a 2 combinations, or you get a failure in a 50 combinations.
Yes.
So as a tester, we can have that comfort level. Like, okay, now these combinations are tested, and so I'm ready to go for that.
There is no.
There is no ready, right? So you have to try and.
You have to try. It's an open space. You have to try. But this allows you to give more confidence than a handwritten test. Right? A handwritten test you can have say 10 combinations, which you are thinking, and half the time developer is telling you what to test. You are gonna think what developer is telling you, and you might miss a completely obvious or a very hard to find, which is only gonna happen in very, very specific case. I can run this whole day. Right? I can try a lot of different combinations. I can have it like what he said, right? I can give weights to certain combinations and maybe reproduce what actually might gonna happen. I can have combinations that never happen in production, but I can still see. So this will give you a lot more confidence. There is something known as 80-20 rule, right? So the initial effort, initial confidence that you get is with the 80% of the effort, but those really hard to find, which is the 20% of the box that you find, requires 80% of the effort, more than the effort of what you normally do. But if you have that time, you can. This allows you to do it. Sorry? There is a saying, who tests a tester? There is only so much confidence that you can have. Right? Otherwise, you can test Clojure and never ship. End user. Who will test the end user? Currently, as
How is generating these combinations?
using the finite state machine.
The finite state machine was for
Representation.
verification of the model. Right?
No, that was the representation of the model. Verification is separate. I did not know.
Okay. So how is the
Separate verification.
from the finite state machine? How is generating those? Can you just explain that?
So, is this map here?
No, don't show me code. Just explain the logic.
So you have. So this is the idea. you have from transitions, and you have from this transition you can go to multiple states. And to go to that multiple state, there can be multiple actions that can be in the same state. So, for example, from new issue to in progress issue, either an admin can reply or an agent can reply. Either of them are there.
So are you using a randomized
Random.
function? Yeah, but don't you think sometimes it's good to even have some amount of determinism within your generated test case? So
I could.
So at least some basic sanity or basic functionality.
So that would be easy, right? So I could just have saying this. I could have something like 25, 30, 50, and this randomizer looks at this value, determines out of which what is the probability of me taking this. It's up to you. I can do that. But then how do you define what is the probability?
So this is not a replacement for your standard.
This is not a replacement.
It's something you use along with.
Yes. I don't recommend just doing this. But this is a good place to invest in. Because what if I want to test this feature with something completely different? Then you will have to write more tests. But if you have this thing kind of a thing, you just need to update that model and it will just relate itself.
But doesn't it also mean that over here you're finite? So I mean, in some sense, you're kind of restricting what a user might do through your finite system, right?
I'm not. I'm just letting it randomize.
No, that's fine. I'm saying, so you're saying that from one step, then after an issue is to something, then either an admin can respond. Yeah, but in the real world, there are, no, so for your case, it might work really well. But in some cases, literally anything could happen. Like, say you have to replicate this for testing Facebook or something like that. And I mean, there might be an infinite number of possibilities. So in those sort of cases, it's hard to represent the possible actions in terms of finite.
So what you do is you have multiple finite state machines which link to other finite state machines. Right? So for example, each feed can have its own finite state machine. And then you can say from issues, I can go to settings. From the Facebook wall, I can go to settings anytime. And settings is a separate finite state machine, and this is a completely separate machine. And within that, there is other separate finite state machine, and so on and so forth. So it's up to you. Then I can say from here, from chat window, I can anytime go to settings. So that allows you to decompose different state machines and update relevant. So if there is a different action in chat window, there's a new button. Everything else remains the same. But now that combination, I can try with every possible. Does that answer it? Any other question?
Kind of like composing, like making efficient composable.
Yeah.
Yeah, modular that you can plug in and enjoy.
Yeah. Right now I'll have to write it. I'll have to worry about it.
The point I'm trying to get is sometimes it's hard to anticipate what will happen.
It's hard.
So you're basing everything on the fact that you're putting a high level of confidence that the set of that your FSM represents the set of all possible actions that could ever happen within your application. Right? So in many cases it's very easy to do. In fact, in most I think applications it's very straightforward. But there are a lot of different applications where a lot of random things could happen.
Agree, but then how would you write this? This allows you to step towards goal. There is a
One example is
so there is a talk by this guy by John Hughes who has tested messaging system, very complicated messaging system, which has time issues and everything, using generated testing. His is a much ahead idea about that. And then he has tested the specification of car for Eastern. I don't know, there's some company, I forgot. And they so in their specification of cars for other different parts, they found like 230 bucks. And in this just the specification, which is huge.
they plus partial, they found like timing errors and
Timing errors in the distributed systems. So this idea has been distributed systems. But they go much higher. Instead of enumerating what is the expected output, they have problems. There are different combinations of this.
So I'm just wondering that reviewing mechanism in your test suite. So it is on a daily basis or some kind of Speedings are there.
So right now, we haven't included in Jenkins because this takes a while. But we can do that. We can tune it to say only test 30 actions. Don't have to. And I can say I know that it will finish in let's say a minute. We have. So right now what I've done is this gave me the confidence.
We are working currently on a project to improve the way we work with it and like we're kind of building a CI pipeline. So currently the limitation for running generative tests and like long-running tests is infrastructure. The way we parallelize these and the way we like manage and orchestrate the testing part of the pipeline. But I think maybe like a month or two we'll be able to run if not on a per commit basis, at least a periodic job for a really long running and really
So then we can have like 10,000 issues with 1,000 actions. And maybe it will finish. So these are, so I started with this, that is, this is the issues details, issue auditing or issue details page that we were looking at. And these are simple actions, right? Admin creates an issue, this should pass, user creates an issue, and like, these are like simulated actions written in terms of DSL, no generation of expected output is generated, but list of actions are not generated. So what I did was, whenever I used to find a bug, yeah, this is a border case one. So this was a bug that we found. I took the steps, put it in the test as a test to check that we found this bug, we fixed it, we should never reduce it. Right? Because of what you said, right? If this generator may not cover all possible cases. Whenever you find a bug, take that, write it in DSL, put it there, that will always test. So at least whatever bugs that you're finding is always going to be tested.
and then there's optionality to
Generate. Then again, if I don't have confidence for finding other bugs, just run through it. Just let it run whole day. Okay.
One of the other subtle aspects of this is that who is actually checking the design, like the sanity of the design itself. It's a model level. So in a way, what Mayank has done is he rewritten the model which the developer had in his head. Now, if there is a mismatch here and models are wrong, most people are communicating about it. That the product manager is something that the developer did something and the test engineer wasn't told them they want. Like, yeah, maybe the developer went and changed some way that they are like massaging data structures or the way they are writing or I don't know, like maybe they are running too many and those things are not managed. So those subtle kind of implementation things and flaws in the design itself, they also can come across because of if you actually apply certain writing and like creating a model that should be the way that that's why I asked you the question, who is test the data? Yeah. In a way, you are using the same model. Yeah. In a way, the developer is testing the DSL.
But the idea is you don't look at the implementation of the developer. You also again do it. There are different again there are different. Because ultimately, even when you are testing, it is what is your understanding of the system. If you don't understand it well, or if you understand it well, somewhere down the line you will have a mismatch. And that mismatch will allow you to fix a lot. So a lot of times I have written it in a different thing, and I found there is a difference. And I went to the developer and like, there is a difference. This is correct. What you do is okay. Let me go fix it. So this allows me to interactively fix either my code or his code and hope that it works. And there are other possibilities that you can do. So for example, let's say you are writing a prime number generator. You have a very fancy prime number checker. And whether the number is a prime. You can write it. I will use a very simple prime number generator. It is very stupid, it is slow as hell, but it works for sure. I know. And I'll generate values and see what values are being generated by me. Because the idea is the same, but the logic and algorithm is different. I can limit values. Right? So it depends on how you approach it, how you take it. Any questions?
If your state machine supports events, would it be possible to accommodate using events like, let's say, you are in a particular state, and after a certain period of time, you should take a particular path. You have to take something similar to it. Would it be possible?
You can. So you can pass around time in your state machine as a global state, right, to that finite state machine. And then you can have preconditions. That I can only go into this state if timer has gone beyond this. And then this state is validated. So you can have a precondition. So right now I don't have preconditions in my finite state, right? But I can have this state, but I can only transition to it only if this condition is true. And then that condition can be your timer. I can say this timer has crossed. Okay, now this is the value. Can I? So now what can I select this? It's possible.
Or automatically you could make the timing property of the transition itself.
Right, exactly. That's what I'm saying. So that condition is.
Like another strategy would be to like if these are truly non-deterministic, like some event happens and then you don't know like how much time it's going to take to complete. Then maybe there are couple of done that with queues. Could potentially uh, try to like
Wait for the queue to come. Give you a result back. From the other
kind
end.
of like fallback on something that exists in a queue. And so that's where the verification, separating the verification is manual. That things can happen, and over time, then you can have some other that has to preset expectation that within 400 milliseconds or within 30 minutes, like my queue should clear and all my actions are completed. Like, maybe you're testing like a job, e-learning job that you maybe you're testing like an event testing. So, I mean, timing expectation for those guys will already.
Any questions? So if you have any questions, you have to contact me. That's my contact. I upload the slides, and we are also hiring for Clojure option. If this sounds interesting to you, I think I hope so. Then you can definitely talk. Thanks.
Thank you, Mayank and Aditya. What we have done is there's some tea, coffee, and snacks behind. You can pick them up. Also, while you're picking up tea, coffee, we'll try and find out the winners. We'll ask Mayank to do that for us. So go ahead and pick up some snacks and tea, coffee out there. While going back, you can put your business cards in the bowl out there. So that will help us also. Okay. Thank you. You can use that opportunity of having snacks, tea, coffee to speak to Mayank as well if you have some more questions. Okay? Thank you. Prasad, Sachin, do you want to add anything? No. People that's important. You have learned something new, try it out. Don't just sit yourself saying, okay, how can I do my domain? You can definitely do it. Thanks. So Asmita from Ideas is one of the lucky members. then Rishabh from Ideas, and Ashwini from Ideas. So you can go ahead and quickly pick it up, and we'll ask Mayank to give it away. Ashwini, Asmita, and Rishabh. Surabhi from Zorian, Sumit Joshi from Cognizant, and Shripad from Greenlight Technology. Please come forward. Shripad. Thanks, Ryan.